David Smith here with yet one more flipped classroom math lesson. 3 tips before we start. First, remember that you can slow down or speed up the playback to suit your needs. Second, you can pause the video at any point to catch up with your notes or jot down questions. Third, you can turn on the captions and read my words on the screen. Okay, today's topic is a walkthrough around the unit circle. So you've already watched a video where we talked about going around the unit circle in multiples of 30 degrees and in multiples of 45 degrees. So what we're going to do in this video is we're going to take that, put that all together on one unit circle diagram that's been shared with you on Google Classroom. So you have a copy of that. You can print it out or pull it up whenever you need it. And then also, don't freak out. You don't have to memorize that whole circle. It will be available to you at all times. And that includes on quizzes and tests. I'm just going to put it right on that document when you get it. You do need to know how to use that, and it's not as simple as it might seem. So I'm going to go through that and talk about all the pieces that are there, and hopefully that gets you up and running for using the unit circle. Okay, here we have our unit circle, and it's marked off with all of the angles that we discussed in that last video. So I'm going to start inside and work my way out. So remember this spot right there, that's the 0, that's 0 degrees, or 0 degree or 0 theta, as we go around the circle. And then as we go around the circle, we go counterclockwise all the way around like so. So I'm going to go do the high points first. If we go from 0 degrees to 90 degrees, we're up here. And then another 90 degrees takes us to 180. Now let's take a look at the radians. You recall, there are 360 degrees in the circle, and that is also the same as 2 pi radians, which is really twice pi, so that's 6.28 radians to go around the unit circle. But we don't decimalize radians. We leave the pi in there. So the full distance around a circle is 2 pi radians. Okay, so as we keep going, down here at 270 degrees, that's 3 pi over 2. And then finally, as we've come all the way back around, we're at 360 degrees, which is 2 pi radians. Okay, so this is here. You have this to look at. You don't have to memorize all the conversions for these essential angles. Okay, so now let's start looking at some of the key coordinate points. Now remember, the unit circle has a radius of 1. So this first point, we haven't rotated a bit. We're at 0 degrees. We've come all the way out a radius along the x-axis. So the x-coordinate of that point is 1. The y-coordinate is 0 because we haven't gone up or down. So this is the point 1, 0. In the same way, as we come up to 90 degrees, now our x-coordinate is 0 and our y-coordinate is 1. Another 90, taking us out to pi radians, we're at an x-coordinate of -1, y is 0, and one more 90 degrees. Now the x-coordinate is 0 and the y-coordinate is -1. So that's zipping around the unit circle in terms of the coordinate points when we go in 90-degree increments. So those are the pretty easy ones. Now the rest are a little bit more complicated, but you have this diagram to refer to when you need it. So again, make sure you understand it and know how to use it. So let's take a look at our first angle, 30 degrees. That's pi over 6 radians. And here are our coordinate points. We used geometry in a previous video to show how to derive these coordinate points. At this point now, you just need to know how to identify them on the unit circle. So remember here, the first coordinate point, that's the x-coordinate, and that's the y-coordinate. So this point on the edge of the unit circle, once we've rotated pi over 6 radians, or 30 degrees, the x-coordinate is √3 over 2, and the y-coordinate is 1/2. Pretty straightforward. Now, here's the deeper meaning in that. In a prior video, you also learned that the x-coordinate is given by cosine of the angle, and the y-coordinate is sine of the angle. And again, we use trigonometry to prove that. We're moving on now, so you just have to remember that. So this part there, √3 over 2, is the value of cosine 30 degrees. Now, if you have a question that asks you for the exact value of cosine of 30, don't put that in your calculator and give a decimal, because that's not the exact value. The exact value is √3 over 2. Okay? Now, here's something that's pretty cool. You take root 3 and divide it by 2 on your calculator, you get the same decimal that you'll get if you do cosine of 30. It works that way, okay? Same thing with 1/2. That's the value of sine 30. So if you do that on your calculator, you'll get 0.5 on your calculator, okay? As we move along, here's 45 degrees right there. Same thing, that's pi over 4 radians. Now this one we know the value of sine and cosine, or cosine and sine, is 1 over root 2. Now we proved that in the last video, or one of the last videos. That's also the x-coordinate of this point right there, 1 over root 2, okay? And as we move around the unit circle, you're going to see all these different values on the outside, and those values are both at the same time. They are the x and y coordinates of that point on the unit circle, and they are the value of cosine and sine of the given theta, okay? So I want to ask you a few questions right now, and you use the unit circle to see if you can answer them. So if you have to pause the video to think a little bit, please do that. Okay, so what's the value of cosine 210 degrees? Take a look at the unit circle and see if you can figure that out. Okay, see how you did. So going around the unit circle, starting at 0, going all the way around, round. Here's 210 degrees, which is the same as 7 pi over 6 radians. And I asked for cosine. So cosine is the x-coordinate. So the exact value of cosine of 210 degrees is negative root 3 over 2. So if you do cosine 210, you'll get a decimal. Then if you take root 3 and divide it by negative 2, you'll get that same decimal, okay? And if you're not sure about that, give it a try. Just verify that for yourself with your calculator. Okay, let's do another one. I want you to do the sine of 7 pi over 4 radians, okay? So what is the value of sine 7 pi over 4 radians? Pause the video, see if you can figure that out. Okay, let's see how you did. Looking around the unit circle, here is 7 pi over 4, and I was asking for the sine. I think it was sine. Hopefully I did that right. I didn't forget. Sine of 7 pi over 4. That sine is the y value. So sine of 7 pi over 4 is the same as 1 over the negative square root of 2, or negative 1 over root 2. And again, if you do that on your calculator, both values should match. All right, another one. What is the cosine of 4 pi over 3 radians? What is the cosine of 4 pi over 3 radians? Okay, here's 4 pi over 3, which is the same as 240 degrees. And cosine is the x value, so that's this, negative 1/2. So if you put cosine 240 in your calculator, you'll get negative 0.5. Okay, one last one. What is the sine of 390 degrees? In exact terms, what is the sine of 390? Okay, so 390 is 360 plus 30 more to get to 390. So that's right here. So that's the same as 30. 390 is an equivalent angle to 30. 30 is considered the reference angle for 390. And that is the same as pi over 6 radians. And I was asking for the sine. So that would be this one right there. That's 1/2. So sine of 390 is 0.5. Okay. All right, so you're going to see questions like that in the exercises and on tests and quizzes. So make sure you can answer questions like that. I want to point out one last thing. In a prior lesson, we learned to distinguish where sine, cosine, and tangent are positive. And you got a little acronym, a mnemonic device to remember that. And it's all silly turtles crawl. ASTC. So what that means is in quadrant 1, that's the all. That means all functions are positive, sine, cosine, and tangent. And you can see here that sine and cosine, all the values there are positive. Now, if you recall, tangent equals sine over cosine. So if sine and cosine are both positive, when you divide a positive by a positive, the result is positive. So we know that tangent is also positive in quadrant 1. So AT that's, I'm sorry, AS, all silly turtles crawl. So quadrant 2 is S. So that means sine is positive in quadrant 2. So sine is the Y value. And sure enough, you take a look, you can see all the X values, all the cosines are negative here. Sine is positive. Now, tangent is going to be negative here because tangent is sine divided by cosine. And in this case, cosine is negative. So if you have a negative divided by a positive, your result is negative. So only sine is positive in quadrant 2. Now we look in quadrant 3, all silly turtles. That's tangent is positive. So that means that cosine and sine are negative here. And sure enough, you can see the values are all negative, and then tangent ends up positive because tangent is sine divided by cosine. If you have a negative divided by a negative, the result is positive. So tangent is positive in quadrant 3. That's all silly turtles crawl. C for quadrant 4, that means cosine is positive in quadrant 4. And sure enough, you can look at the x-coordinate, which is cosine. These values are all positive. Our signs are negative. And to get tangent, we're going to have a positive divided by a negative, or I'm sorry, a negative divided by a positive, which gives us a negative for tangent.
Now that you've watched the video, jot down some notes or questions for our next class. You can also re-watch the portions of the video that you didn't understand so well the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.